Hello and welcome to this Tales from the Hangar Aviation Rarities episode about the Supermarine Type 322. It was a World War II prototype carrier-borne torpedo dive bomber and reconnaissance aircraft, and it was designed to meet the 1937 requirement Specification S.24 for replacement for the British Royal Navy's Fairey Albacore biplane. The S.24 aircraft requirements were: it had to be robust enough for deck takeoffs and landings, have a low landing speed and good forward visibility, and speed and range would have been greatly improved over the Albacore. The gross takeoff weight, which in the land-based version was not to exceed 10,500 pounds, was to include 1,500 pounds of bombs or a Mark 11 torpedo. The aircraft was also required to be able to dive bomb at an angle of 70 degrees to the horizontal, and the need to stow the aircraft below the deck, transfer it to the flight deck using the aircraft's lifts. This imposed overall restrictions on its dimensions, and the wings also had to fold. So 7 manufacturers were asked to put forward designs. Bristol and Blackburn were the nearest to being selected. In the end, orders came for building a prototype were placed with both Supermarine and Fairey Aviation for what became the Barracuda. On the 25th of January 1938, the senior staff at Supermarine met with the Air Ministry, and it was decided the variable angle wing offered the best solution to the problem. To avoid complications, it decided to use fixed landing gear, provided it would not interfere with the performance objectives. It was later decided that air brakes and brake flaps included for dive bombing would also be removed to keep it simple. The variable incidence wing allowed the fuselage to be kept at the optimum angle, which was good for visibility while maintaining lift, particularly useful for carrier-borne aircraft with tailwheel undercarriage. The Rolls-Royce XE 24-cylinder valveless engine, then under development, was initially chosen as a power plant. The Bristol Taurus was also considered. However, the company ultimately decided to use the more affordable Rolls-Royce Merlin engines, despite the fact they were liquid-cooled. Mike Lithgow joined Supermarine as a test pilot in January 1945, and this is what he recalled about the Dumbo. On the 17th of May 1939, 2 prototypes of the Supermarine Type 322 were ordered to Specification S.24 and they were allocated to the military serial numbers of R810 and R815. The aircraft was to have a crew of 3. And by chance the high wing configuration, which is best suited for variable angled wing, provided the observer with an excellent downward view, and wood was chosen as the main material for the Type 322 airframe. This was partly due to the shortage of light alloys, and also to allow for faster production. The fuselage was constructed of spruce. The framework consisted of plywood frames and 4 spruce spars, covered with a skin of diagonal plywood strips, and glue was used to join the framework to the skin. And the oversized contours of the fuselage earned the Type 322 the nickname Dumbo. The stabiliser had no spars and formed a monocoque structure consisting of spruce ribs with a diagonal skin. The elevator and rudder were covered with fabric. The semi-braced main landing gear, equipped with Vickers hydraulic shock absorbers, had a track width of only 6 feet 4 inches, that's 1.93 metres. In addition to the tailwheel, an A-frame tail frame with an arrestor hook was installed. The Type 322 could eject with an overload of up to 3G. Although the main wing spar was made of Dural, the rear spar and ribs were wooden. The first prototype, R810, used plywood skinning, but the second prototype, R815, had folding panels covered with oar cord to increase torsion rigidity. The forward part of the wing centre section was formed by 2 65-gallon or 295-litre fuel tanks, which were part of the main structure of this aircraft. The sparless woolen ailerons were covered with a 3-layer of plywood skin. A double hinge joint allowed the wing panels to fold rearward along the rear fuselage. The leading edge slats were all metal covered and run on machine guides, when the trailing edge flaps were mounted spanwise between the fuselage and the ailerons. The flaps were connected to a variable angled wing, which could be extended to the maximum of 60 degrees, while the maximum angle of attack of the wing was 15 degrees. Since the wing centre section of pressure was close to the main spar, almost all the flight loads were supported by the phosphor bronze bearing of the forward spar. Small vertical loads were supported by the rear spar. The wing pivoted relative to the forward spar, and its angle of attack was varied by 2 screw jacks which connected the rear spar to the fuselage. These jacks were driven by a 1.5 horsepower electric motor via a chain drive or manually by means of a hand wheel. A selector allowed the pilot to change between the 2 control methods. The wings were normally mounted parallel to the fuselage, structurally horizontal. The angle of attack in the fully extended position was 13 degrees, giving a maximum landing angle of 15 degrees. Initially, only the handwheel control was used, and although it was easy to move the wing with the aircraft on the ground, it was extremely tiring to do so in flight, with the electric motor operating at full power. Micro switches at the limits of wing travel switched off the electric motor. The screw jacks were immune to any accidental change in the angle of attack. because they were subject only to vertical loads. The cockpit instrumentation included a Fairey blind flying panel. Many of the controls were from the Spitfire, including elevator trim tabs, trim indicator and rudder offset compensator. The first aircraft of specification S.24 37, R1810, powered by the 1,300 horsepower Merlin 30, made its maiden flight over Worthy Down on the 6th of February 1943, and it was flown by Supermarine test pilot Geoffrey Quill. And I will just add, the original 322 programme was due for completion in early 1941. This is all delayed owing to the high priority for building Spitfires. The second prototype, R1815, flew shortly afterwards. In addition to the revised wing covering, the second machine featured a 1,620 horsepower Merlin 32 engine, along with a taller, sharper vertical stabiliser and rudder, plus a four-bladed prop was fitted later. Factory testing continued until November 1944, when R1810 was sent to the Royal Aircraft Establishment at Farnborough for extensive flight testing. And at Farnborough, testing focused on controllability, particularly pitch and roll and stability, and controllability during takeoff and landing. The RAE regarded Dumbo as a purely experimental aircraft. Since the slats were automatic and the flaps were linked, the pilot's landing actions were no different from those of a conventional aircraft pilot, who simply extended the flaps. When a conventional aircraft was flying slowly, the wing angle of attack increased, with the tail dropping. This effect was enhanced by the wing's lift. With the pivoting wing, the Type 322 pilot could maintain a nearly constant fuselage angle of attack during approach to the ground. The pivoting wing could also provide the pilot with excellent visibility, and the pilot could select intermediate wing and flap settings for slow flight in poor weather, and with appropriate settings the aircraft could easily take off from 3 points. Another unusual feature was the nose being lowered significantly when the aircraft was approaching with the engine off, in addition to adjustments to the fuselage level could be made during the approach with the engine running. When the Type 322 left the ground, a large nose-up trim developed, limiting the maximum flat setting and wing angle of attack to 42 degrees and 11 degrees respectively on takeoff. As the wing angle of attack increased, the stall became progressive and more pronounced. Although the aircraft had good directional stability, it was laterally unstable and very slightly pitch unstable, making it difficult to fly in poor weather. When approaching with the wing set and maximum angle of attack and slats open at 75 mph, aileron control was light and effective. However, rudder control was ineffective and the elevators required considerable movement. Ineffective rudder control resulted in the tendency to unbalance and increase the rate of turn, which in turn led to a pitch-up angle, stall and spin, which could only be prevented by closing the throttle and deflecting the rudder and ailerons in the opposite direction. At all angle of attack settings, the main wheels left the ground before the tail wheels. The aircraft climbed quite steeply. On takeoff, the wing setting was limited to 11 degrees, due to the need for sufficient elevator control to prevent the aircraft from stalling, with the engine running at full power. Also during the test, the landing characteristics of the aircraft were evaluated with the wing set in the range of 10 to 15 degrees, and it was found that the difficulty of piloting technique increased with the increase in angle of attack. At 15 degrees, the approach speed was 75 mph. Sober calculation was important, and it showed that if the setting was the 3-point landing, then the landing on the main wheels alone would result in a bouncing landing of large offsets. However, at 10 degrees, the landing was simple, and this setting was recommended for normal carrier operations. Locking the slats in the closed position increased the stall speed by about 12 mph and increased the wing stall. Elevator control was greatly improved, but at the same time became much more sensitive. Testing at Farnborough was completed when on the 22nd of June 1945, the first prototype R1810 engine developed a glyco leak and the aircraft caught fire in mid-air. Famous pilot Eric Winkle Brown, who was in charge of the tests and piloting the aircraft, shut down the engine and made a successful landing with the engine inoperative. Although only the nose of the aircraft was damaged, the damage was considered too severe to warrant repair. Supermarine continued to fly the one remaining aircraft, R1815, which was eventually fitted with slotted ailerons. R1815 was used in 1946 as a chase aircraft for the low-speed handling trials of the Supermarine Attacker jet fighter. As for what happened to it afterwards, I guess it was scrapped. And of course the Barracuda got selected. Thank you so much for watching. Drop in a comment, press a like, click on subscribe, and please share and spread the word. Always appreciated. And all the best. TTFN.